There is one logistics mod above them all. With just one block, you can send an infinite amount of items, send fluids, power, and more, and quite literally get to code in Minecraft. This mod is Super Factory Manager, and with no guides or proper way to learn it, I've taken it upon myself to create this video for you today so that you could do something like this. Welcome. Thank you for joining me on this trip through Super Factory Manager. No time to waste. Let's get talking about what we're going to need. We're going to need a factory manager, inventory cables, a label gun, then factory manager program disks. Now you're fully ready to begin. This is a logistics mod, so we're going to need things to transfer from one place to another. This could be a chest, a furnace, a sink, or even energy. But to begin learning, we're going to start with just two chests. You start off by adding a disk into this slot, and then you click edit. This is all you need to do to get your factory set up. If you have another chest that's not somewhere here, you would just use some inventory cables, and this would still work. You can transfer items to and from each chest. But for right now, let's have the chest here. And yes, this is indeed programming. And as bad as this looks, it's actually not that difficult. By the end of this, you're gonna know how to do that. So let's start simple. Name, and then the name. Every code you want to start like this so that your disk has a name. That means if you ever write a bunch of codes, you will know which one's which. But aside from that, we need to start telling this what to do. There's two ways to get Factory Manager to run your code. This is via one of these two commands. You can automatically run all the code that you write in here using an every 20 ticks command, or run all your code that you will be writing using a redstone pulse. In most cases, people want their code continuously running, so in our case, you want to write every 20 ticks do. After this, you want to hit enter a few times and type end. The reason you want to do this is because in between those two is where you're going to write all of your code that you want to run. Now remember, a logistics mod just inputs and outputs. So we want to input from this chest, output to this chest. Or for example, we want to input from this cube, output to this furnace. Or input from this sink and output to this sink if you want. And thankfully, it's pretty easy with Super Factory Manager. All you want to do in this area is hit tab, just so that our code is indented, and then write input and output. The nice thing about Factory Manager here is that it is very language friendly. Almost the way you speak your sentences is how you're going to write your code. So we input from and output to. This is effectively what Super Factory Manager is centered around. And now to finish our code, we just type in chest 1 and chest 2. So there we go. Our code is now finished. There are no errors. It does, however, say label chest 1 is used in the code but not assigned in the world. So right now this thing knows to take from chest 1 and output to chest 2. But which one of these is chest 1 and chest 2? Because what if I want this one to be chest 1 or this one? Either one. And this is why we have a label gun. You shift right click on the manager, and now if you right click in midair, you'll see there's a chest 1 and chest 2 option because we use them in the code. So all you want to do is select chest 1 and select the chest that you want to be chest 1, which is this one, and just right click it. We also want to do the same thing for chest 2, and once we've got everything labeled, we just right click the manager. There you go. Now there's completely no errors. So every 20 ticks, which equates to 1 second, it'll take from this chest and output to this chest. And although this is very simple, you now know how to use Factory Manager to transfer your items. What's nice about Factory Manager is that it has no limit. It can transfer everything from one inventory to another, unlike pipes. So even if it seems a little bit complicated to use Factory Manager for such a basic purpose, well, there definitely happens to be some merit. But okay, looking at this more advanced code, you can see there's way more to it. And that's because you can get very specific with Factory Manager. So for example, I can tell it what to input and what to output. So if I set output stone to chest 2, what we're now looking at is it'll take everything from chest 1, but only output stuff to chest 2 if that stuff is stone. So here's an example. I put in some stone, the stone goes in here. If I put in the inferium seeds and the stone, only the stone will go. I can also put stone here instead of here, and that'll do the exact same thing. It'll only take the stone. Now that's pretty useful, but you can actually make it this even better. If I put little asterisks around the stone like this, then what that means is if the item has stone in its name, so for example, redstone dust, that has the word stone in its name. This means if I put normal stone in, it'll of course go, but now if I put redstone dust in, that'll also go. Check this out. Without these asterisks, redstone, it's not going to go anywhere. And that can come in pretty dang useful. Say you have redstone and redstone blocks in here, then you can just put redstone in asterisks and it'll send everything over unless it isn't redstone. Here's another interesting function that'll go before the from, except. This goes before a type of item, so if I say except stone, now that does exactly what it sounds it does. It takes everything that isn't stone and transfers it to this chest. So as a quick recap, you have the name, you have a trigger like every 20 ticks or redstone pulse, and everything inside is indented. You just have an input output. So far, so good. Input except stone. If I set asterisks, it'll do exactly what you expect. Put in redstone, that won't go because it has stone in its name. Here's another very interesting thing that goes before the from. Retain. The retain function, what it does is say I put 2 stone in here, it'll send one of the stone over to here, but retain the other one. That can be somewhat useful, but it can be especially useful if you do retain one on the output, because then if I put in a bunch of stone, it'll retain one in the output, so it'll have 1 stone in here while the rest stays here. I'm going to write these 2 functions that we've learned down here just so you don't forget. Let me also add start. That's because some things you can specify before, so you can say retain 1, but some things you put at the end, like topside. I'll get into that in a second, but I'll label these parameters as end right here, just so you know that they go at the end, while these ones go at the start, which is before the from. Now, why am I teaching you all of this? Well, that's important if, say, you're trying to automate a furnace. For anyone that doesn't know how a vanilla furnace works, the food has to go in through the top, the fuel has to go in through the side. So let's modify our code here to input from chest 1, output to furnace. You should always design the skeleton of your code first, where it's just inputs and outputs, just so you know what you're looking at, and then from there, finish designing your code. So let's pull the labels by shift-clicking, then we will assign a chest 1, and assign a furnace, and then right click to push this back in. So now we're inputting from chest 1, outputting to furnace. Let's put in some stone and see what happens. Boom, the stone goes to the top. Now let's grab some coal and put it in here, and you see there's a little bit of a problem. The coal is not supposed to be there. We want the coal down here. Now there's multiple ways to fix this. We can do output coal to furnace south side, for example, first. So that means first we're taking from the chest. We're going to output the coal, then we're going to output the rest. And in fact, you can say except coal, just to be sure that the factory manager will not accidentally send the coal up here. But now that I've specified south side, which is from this direction, factory manager is going to put the coal on the bottom and everything that's not coal on the top. Now we've successfully automated a furnace by taking from the chest, outputting just the coal to the south side, and outputting everything that's not coal just into the furnace in general. Or you could do topside if you really want to be sure. Now if we want to take what the furnace has, all we have to do is go in here and write input from furnace. This, however, is problematic. This is because we're inputting from the chest and we're inputting from the furnace. I'm not going to get into too much detail, but every time you input from someplace new, if wherever you're inputting from is not going to the same output, then you want to write forget before that. What forget does is it forgets where you were inputting from before, basically starts a clean slate, as if none of this existed. Now you start from here. What I want to clarify is what I was saying. Say you have 3 chests and 1 furnace. You can input from all of these 3 chests so long as they go into this 1 furnace. But if you didn't have this forget here, you'd be inputting from here and from here, meaning you're inputting from the chest and from the furnace, and then outputting them both to the chest. Although you won't experience any problems, that'll end up cycling items in a way that could make you a little laggy. So that's why we have forget. But after that, we input from furnace and output to chest. And there we go. Now look at this big problem. We've just taken everything out of the furnace. We only want to take out what's here. This is where the slots function comes in. If you hit Control-I on your keyboard, all the slots in a furnace now have a number. Slot 0, slot 1, slot 2. I want to extract from slot 2, input from furnace slots 2 and I'm going to add that to our list. This goes at the end. So now this is pretty self-explanatory. Factory manager is only going to take stuff out of the furnace if it's in slot 2. So watch it finish, and there we go. There's our smooth stone. So we now know 4 functions. We can input all items except for one. We can retain, and let me give you an example. If I put output retain 1 coal, remember this is a start function, so this will always go right after output. But now that I have output retain 1, that means it should only send 1 coal and no more. The rest of the coal is in here. That can be useful if you're using one item to power multiple machines. So let's pause here for a moment, because you are almost ready to build that entire contraption. Believe it or not, with this little simple furnace automation, you're almost ready for all of that. Best way to learn, of course, is in a creative world. Just build yourself a little practice setup and experiment with it. But here we go. One last thing before we need to build the behemoth. Factory manager can send things that are not just items. It can send fluids, it can send power. This phytogenic insulator happens to need both, so let's make one from scratch. First, we name it, then we give it a trigger, so every 20 ticks do. 20 ticks is the fastest you can send items, fluids, gases, and whatnot. When it comes to energy, you can actually do every 1 ticks. Remember, only electricity. We need to put an end after both of these, and now let's get working. So we want to input from cube and output to Fido. We want to make the skeleton of our code first, so let's just make it simple. Input from sync, output to Fido. And right now factory manager is not happy because I have not specified that we want to take energy every 1 ticks. It's telling me you can't do every 1 ticks, but if we just do that, I think that should be fine. It's not fine. Let me leave it at 20 ticks and change it later. So let's label our cube, let's label our Fido, label our sync, push all the labels. So let's take a look. Nothing's ending up in our Fido. Even though we're inputting from the sync and we're inputting from the cube, the Fido has no energy or fluid. And that's because there's 2 things we want to do. First of all, the energy cube. This thing we have to specify a side. Let's specify input FE from the cube top side. And then we actually have to specify that we want to output FE as well. There we go. Now it's cooking. And now we can change it to 1 ticks because yes, every 1 ticks when it comes to energy. And it's no longer giving us an error. It was before because when I didn't have FE, it was thinking I'm trying to send something else perhaps, like items or fluids, but again, every 1 ticks is all we can do. Now by the way, I wrote FE like this because this is how Super Factory Manager reads items. It reads type, mod, item. This is the format and it's separated by these colons. So when it comes to normal items, it's just item, colon, the mod, which we can just put Minecraft, this means vanilla, and then the type of item, which one in particular, so in this case coal. This would be a valid way for Super Factory Manager to read items. You could put it to the test by plugging in output except item Minecraft coal to furnace. This is going to do the exact same thing, which means output everything that's not coal to the top side, so output the stone. In this case with FE up here, the type is quite literally FE, electricity. Then I put a colon. The mod doesn't actually matter because FE is part of Forge. We don't need to specify a mod. So that means we can just put another colon. You can think of there being no mod in between these 2 colons. And then at the end, when we actually need to specify the type of thing we're sending, again, we don't need to do that because we already specify. We're sending electricity, and really this is not necessary, and that's why it's FE with these 2 colons. And that's actually why when it comes to this sync, the reason this is not sending water is because we didn't specify what we're sending. Right now it's trying to send items, but we want it to send fluids. Input fluid, output fluid. Now take a look at this. We have water in our Fido. So in between these 2 colons, we could put mod, so for example, mechanism, and then lithium. This would be completely valid, and this would send only lithium from the mod mechanism. But we're inputting from a sink. There's only water in here. That means we could just input everything here, output everything here. And now, we're actually ready to build the behemoth. Let's work through it together. This will be really quick actually. We give it a name, we give it a trigger interval. In this case, we take 1 ticks. And then we input FE and output FE. Remember our little end. And now for everything else, we do every 20 ticks. Remember to do the end, indent. And now let's see. These Fidos are going to need power. They're going to need water. They're going to need fertilizer. We've already got the power covered, so we're going to need the water, which we specify by saying input fluid. Then we're going to need fertilizer. When it comes to phytogenic insulators, the best fertilizer is PhytoGrow. You can make things simple by putting phyto in asterisks from a fertilizer chest. So say I want this to be fertilizer chest, this will input everything with the name Phyto, so in our case PhytoGrow, and send it into the phytos. We also need the seeds themselves, so what I'm just going to do is write input seeds from the main chest. We're inputting from all of these different things and outputting them to our phytos. So let's write that down. Output, if we don't specify anything, it will send everything, so we can just do that. Remember, this only applies to sending all items, so if we're using fluids, we do want to specify output fluid to phyto. Now we need to give this some labels, so let's grab the labels. Our energy cube is here, our fertilizer chest is here, the main chest, in my case it's a backpack, I'll be using this one, the phyto. Now, I'm not going to be doing this. I'm not going to label each phyto. If you hold control on your keyboard and right click, what it'll do is it'll automatically label every single block that's touching it if it's the same block. So now we've just labeled all of these phytos, and now we want to label our sink. So let's get back here, label the sink, push our labels, and now we are officially running in some of the phytos. Here we go, this one received PhytoGrow, and it received seeds too. But there's still a problem. This one in particular is with the energy cube. When it comes to energy cubes, we have to specify what side we're taking the energy from. There we go. Now look at this. All of our energy is filling up, Phyto's full. These are pretty weird, so yeah, just remember top side and make sure your mechanism is actually set to output on top. So okay, our Phyto is running now, but there's still a big problem. First of all of our Inferium seeds are being clumped up in stacks in some of these phytos. I want one seed in all of these. There happens to conveniently be an each function. This is not one that goes at the start, meaning right after the output, or the end, which goes after the place. This is in the middle, so this goes after the to, and you just say output to each phyto. Now what this is going to do is it's going to take the seeds and output them to every phyto. The problem is, it's still stacking them. Here's a very simple way to solve this. Output 1 to each phyto. It's really just that simple. So I'm gonna grab a bunch of seeds, put them all in here, and look at this. We've made progress. Now all of these phytos have one seed in them. Now the way phytos work is after they process the seed, they'll output it as well as the result. So now we're gonna take the stuff out of phytos. Remember, because we're now inputting from the phytos, we're gonna wanna do a forget. And then we just output from phyto and output to main chest. That's it. But wait a minute. We're going to run into the same problem as earlier. It takes everything out. So we hit Control I, we take a look. We'll want to output from these slots. So we just do slots 2 through 5. And now look at this. We'll only be taking out of here. And also, would you look at that? Now every single phytogenic insulator is running. The beast has just been built. Now there's one more thing that I should tell you about. These are if statements, and I don't know, sometimes you might need them. And here's how they work. If a certain inventory, in my case chest 1, has, and now there are several operators. First of all, you can just do 20 stone, for example. But if you wanted to have more than 20 stone, then you write this. If less than this, if less than or equal to that, you get the point, and end. So this is how we set up our if statements. If inventory has some amount of items, then this is what you do. And then you can write all of your code inside. And in the end, it looks like this. So if chest 1 has 20 stone, in my case, I should have put an equal sign because that's what it wants. But if chest 1 has 20 stone, then input from chest 2 and output to chest 1. Pull our labels. Here's chest 1, here's chest 2. And now look at this. Let's put these in here. These aren't going to move unless this one has 20 stone. So let's grab our stone here and get 21 stone. Let's put 21 stone in here. Still nothing's happening. We take 1 stone out and look at this. It's still not going to run because I forgot to push the labels. But there you go. Now you see these are in here. Let me just demonstrate. Let's put these in here. These aren't going to be in here, but as soon as we have 20 stone, here they are. Yeah, do what you want with that, you Nano Super Factory Manager. Goodbye.